Our next speaker is Professor Maya Rossin-Slater. She's an associate professor of health policy at Stanford University in the School of Medicine. She's also a senior fellow at the Stanford Institute for Economic and Policy Research, a research associate at the National Bureau of Economic Research, and a research fellow at the Institute of Labor Economics. So today she'll be talking about extreme heat in early life and adult earnings.
Thank you so much for having me. It's really a pleasure to be here to be speaking to this audience today. So I'm Maya Rossin-Slater. I'm a health economist by training, and most of my work focuses on policies and other factors affecting families with kids in the US and other high-income countries. A part of that work has looked at the intersection between the environment and early life health. And in particular today, I'll be sharing some of my research that we've done that analyzes how exposure to extreme temperature, and in particular extreme heat in utero, so during the prenatal stage, as well as in the first year of life, affects individuals' adult outcomes. So just to kind of motivate this line of work, there's widespread scientific consensus that exposure to extreme temperature can be harmful for human health. Largely, and I'm not a climate scientist, but my understanding is it's largely due to an overload on the body's ability to sort of self-regulate. And certain subgroups are particularly vulnerable to this, and that includes fetuses and infants, because their bodies, their nervous systems, sympathetic nervous systems are still developing during these stages. And indeed, prior research has indicated that exposure to extreme heat during pregnancy, as well as in the postpartum period, has adverse impacts on key indicators of infant health, including birth weight and infant mortality. So for example, this is from a study by Duchenne, Gurian, and Greenstone from 2009 that essentially shows that exposure to heat above 85 degrees Fahrenheit in the third trimester of pregnancy leads to a reduction in birth weight. Now, what about the potential impacts on long-run outcomes? Well, here we can draw on a large and interdisciplinary literature that has documented the way in which the early life environment, including the in utero period, as well as say the first, 2, 3, 4, 5 years of life, really can shape long-run outcomes along a wide variety of margins, from health, both physical and mental health, to human capital, educational attainment, cognitive and non-cognitive skills, adult earnings and adult economic productivity, life expectancy, and then on to the next generation. There's sort of a lot of hypotheses for how all of this might operate. One of the key hypotheses for this line of research is the fetal origins hypothesis from Barker, which sort of argues that adverse conditions in the in utero period can, so to speak, program a fetus to have worse outcomes in adulthood. And there have been studies kind of documenting this phenomenon using a variety of these sort of big, large-scale events or shocks that might happen in the in utero period, from the 1918 Spanish flu pandemic to the 1944 Dutch famine, to a variety of wars and other conflicts, Chernobyl, fasting during Ramadan, nuclear radiation testing in Norway, air pollution, lead, lots of things. And yet, despite the growing concerns about extreme temperature and climate change more broadly, the research on the long-term impacts of early life exposure to extreme temperature has been more limited, but I think is increasingly important for really understanding the full impacts of climate change. So for the rest of this presentation, I'm going to share with you the results from this research that I did jointly with Adam Eisen and Reed Walker, which was published in 2017 in PNAS, in which we tried to shed light on this question. Just a little disclaimer, we're using pretty restricted data from the Census Bureau, so everything that I'm showing you here has been reviewed for disclosure. So when we think about sort of the empirical exercise of trying to understand the long-term causal effect of temperature on a variety of outcomes, we're going to face at least two, if not more, challenges. So first is sort of a classic causation versus correlation challenge, right? Exposure to temperature is not randomly assigned, both because of differences in where people live and sort of even within small areas, there's sort of microclimates and the way in which our society is pretty segregated by race, by ethnicity, by socioeconomic status. We can't infer exposure, even within small geography, as being driven only by temperature alone, rather than those other differences between individuals. And then if we think about comparing people, say, born during different months of the year, who might experience different average temperatures during the in utero period, well, that's also challenging because we also know that selection into who gives birth in different months of the year is not randomly assigned. And so that's not going to allow us to sort of disentangle the causal effect of extreme temperature from these other differences between individuals born in different periods of the year. And then secondly, there's a big data challenge, right? So we need to be able to have information on when and where people are born, which will allow us to then, use weather data to say something about their exposure to temperature, and information on what they're doing as adults. So in terms of our solution to the first empirical challenge, here's what we're going to do. We're going to leverage the fact that temperature exposure can vary at a fairly fine grain level, both across geography and over time. So essentially, our data is going to allow us to observe individuals' locations and the exact date of birth, and we're going to merge that with daily weather data. And we're essentially, for any given individual, we're going to be able to construct their total days of exposure to various temperatures over different days, over different periods of development, both in the in utero period and in the first year of life, while controlling for location, race, sex, and the day of the year, so each of the 365 days of the year in which individuals are born. And I'll go through an example to give you a bit more intuition on how we do that. And then the second empirical challenge, our solution is to use pretty unique administrative earnings records data. So these are data that are drawn from state unemployment insurance systems, UI systems. And so almost all employers that pay taxes into the UI system are required to contribute their data into these databases. So it covers a very large share of the US workforce. In this study, we focus on data available for years 1998 to 2007. Our set of cohorts that we're going to be analyzing are individuals born between the years of 1969 and 1977. We're going to do so in a set of states that continuously contribute data to this database, and that's going to lead us to have data on about 12 million individuals. So just to give you a little bit more detail, so the data set is called the Longitudinal Employer Household Dynamics, or the LEHD database. So the key thing with this data is that it's these earnings records that are available on a quarterly basis for every individual, for every job that they work in. And that data set is linked to something called the Numident file from the Social Security Administration, or the SSA. The Numident file is another administrative data set that the US government holds, and it contains information on the place of birth, exact date of birth, and date of death of the individual has died for all Social Security number holders in the country. So we're going to restrict our attention to the set of 24 states that have continuously contributed their data to this data system. And again, we have about 12 million individuals. And then we have rich, widely used weather data that's essentially available at a very fine level of geography at 2.5 by 2.5 kilometer grid of the US over our time period of analysis, where we have standard information like daily mean, min, and max temperatures and precipitation. Okay, so the way that we proceed then is that for every individual, we can see their information on their exact date of birth and their county of birth. And then we're essentially going to take our weather data and scale it up to the county level using population as a weight. And so we're going to construct the number of days that each individual is exposed to different temperature bins. So for example, in centigrade, temperature above 32 degrees Celsius or between 28 and 32 degrees, how many days did the average temperature reach those levels over different periods of exposure? So the thought experiment is as follows, right? Suppose, and I didn't actually look this up, so I'm not sure if this is true, but suppose there were a heat wave in August of 1980 in Santa Clara County, okay? Take two white females who are both born in Santa Clara County on January 1st. One was born in 1981 and the other was born in 1980. Was the one who was exposed to the heat wave, meaning she was born in 1981, experiencing different earnings 30 years later as compared to the one that was not exposed to the heat wave in the utero stage, right? And imagine doing those sets of comparisons across all the possible race, by sex, by county, by day of year combinations. Okay, just to give you a sense of the variation of temperature over a time period of analysis. So here I'm showing you maps of the United States where we look at the deviation from the county mean number of days, specifically here between 28 and 32 degrees Celsius, right? So the yellow to red colors represent hotter periods where there's more than average number of these days, and the blue represents cooler periods when there's fewer than average of these days. And so you see that there's some variation both across time and across geography. Some years are cooler than others, some years are warmer than others. 1980 happened to be particularly hot. Okay, and so here is a visual representation of our main results. So on the x-axis, I'm showing you the different temperature bins expressed in Celsius here. And the different lines here denote different periods of exposure. So first trimester, second trimester, third trimester, and then age 0 to 3 months, 3 to 6 months, and 6 to 12 months, okay? And so what you see is that across all of those periods of exposure, when experiencing very high temperatures above 32 degrees, each additional day of exposure in those periods to that type of temperature reduces individuals' earnings measured between the age of 29 and 31. And I'll show you the exact magnitudes here. So this is about $40, right, in annual earnings. So this is from one additional day of exposure. Okay. The other thing that we do in this analysis is we consider what happened to adoption of air conditioning over the same time period. And it so turns out that during this time period for these cohorts, there's actually a big expansion in the adoption of air conditioning across the country. And so essentially, the share of households, this is from the census, the share of households that had air conditioning increased quite a bit from 1960 to 1970 to 1980, right? But it did so not uniformly. And so the next thing that we do is we essentially interact exposure to various temperature bins with the share of the county whose households had air conditioning at that time, to check whether access to air conditioning appears to mitigate the effects of extreme temperature. So I apologize for this very busy table, but the point here is to show you the magnitudes of our coefficient estimates. And the key thing to take away is that in the left-hand, the two left-hand columns, we see mostly negative numbers, meaning that exposure to extreme heat without air conditioning reduces long-term earnings measured at ages 29 to 31, whereas access to AC, so suppose a county had 100% air conditioning adoption, this actually does not exist, so this is sort of an out-of-sample prediction, but in the case if a county had complete household AC adoption, we would basically completely mitigate the negative effect of extreme temperature. In terms of magnitude, so we estimate that one extra day of exposure to temperature above 32 degrees Celsius leads to about 0.1% lower earnings around age 30. Just to give you a sense of like how this compares to other things. So economists estimate that the return to an additional year of schooling is about 10%. Okay, we talked about the 1918 flu pandemic earlier. So one study suggests that in utero exposure to the 1918 flu reduced male earnings by about 5 to 9%. In another study with the same set of co-authors, we found that a 10% increase in air pollution exposure in the year of birth led to a 1% reduction in adult earnings at the same age as in this study. So here, of course, the effect size is much smaller, but that's, I think, to be expected because we're just talking about one additional day of extreme temperature during the in utero stage. And as, you know, we're predicting to increase the frequency of such days, you know, we could expect that this effect could be larger. But importantly, these long-term impacts are almost completely mitigated by air conditioning adoption. And so, you know, I think in terms of what this means, by a construct, a study of long-term impacts, we have to look in the past. Right, so we can't really estimate long-term impacts using modern data because we have to use data on individuals who were born, you know, decades ago. And so, as scientists predict an increase in global mean temperatures in the future, which is, you know, largely driven by this rightward shift in the upper tail of temperature distribution, so more and more extreme heat. You know, we could expect that some of these effects might become larger. As people are exposed to more and more extreme heat. Of course, as we show, there's also an important role for adaptation and mitigation, namely through access to air conditioning. But we know that unequal access to AC, both within the US and of course globally, suggests that, you know, there are important implications in terms of health equity and its ties into economic inequality that operate through exposure to extreme heat, and especially during this sort of very vulnerable period of human development, namely the fetal stage and the early infancy stage. So that's all I have. Thank you very much.